For those who are interested why I set the solder mask expansion here every time in the board setup is that when the board solder mask expansion is set to a non-zero number, I can see around the pads the expansion. So when I place, let me show you. When I place the via, I try to, you can see the circle around the via. So I try not to overlay the via circle with the solder mask expansion. It means that the mask will not join with the unmasked part of the via. It means that the via will not suck out the solder from the pad. This is quite important, and I recommend to you to set the solder mask expansion to non-zero value, for instance 0.05 or 0.07, which is a standard expansion for solder mask, and then you can place your vias on better spots, as I said, to disable or to avoid the vias to suck out the solder from the pads. Because when the vias are unmasked completely, it's a tunnel for the solder, and when there is no solder mask in between the via and the pad, there is a section channel for the solder. So this is the reason. Hello, Aslana. I'm happy that you like it. So back to board setup. Solder mask expansion was explained. I like to set the minimum text height to 0.7 millimeter. This is verified size of the text that is easy to read and small enough to be easily placed on the PCB, because sometimes when the components are close together, there is no space for the reference designators in select screen, especially when there is a lot of components, for instance R155 or 288. This is quite long string, so the small text size helps when you have struggles with the reference designators placement. 0.7 is my recommended value. 0.3 is my favorite thickness for, let's say, normal tracks. 0.5. Now I'm not talking about the net classes. I'm not talking about any differential pairs, any impedance controlled tracks. I am speaking about normal analog or very slow digital signals. 0.5 for, let's say, low power, 0.1 for higher power, and when there is a need on this board, there is no need for that. I am using 2 millimeter, 2.5, 3, it depends. But 0.3, 0.5 I use almost on all boards. It's quite comfortable to work with. The PCB layout is still neat, tidy, and well, I don't want to use the minimal thicknesses because the PCB manufacturing is then not challenging the machines at the PCB manufacturer's shop are able to create even tinier tracks, but I like to have some headroom. Usually for dense boards, I use the vias with 0.45 outer diameter and 0.25 drilling, but this time there is enough space, especially on this board. This board will be used as a, not prototyping, but not final design. I will tune the design, I will play with it, I will even change the circuitry. I hope I will not, but there is a possibility. So there is quite enough space in between components, so I don't need to make the vias so small. So I will keep the default values of 0.6, 0.3, which is the default net class for KiCad, but as you can see, there is 0.2 track width and 0.2 clearance. I like to have some headroom, so I primarily use 0.3. When there is a lack of space, I will go to 0.2, but usually not below. This board is quite huge and not populated much, not dense much, so 0.3 is a good balance point. Sometimes I use even 0.5 millimeter for PCB layouts for such boards because it's thin enough for the layout, and yeah, as I said, I don't want to go too low. So this is it. And as you can see, the board is quite large. This is the size of the PCB. I don't like the non-rounded PCB size, but this time, as I said, this is not a final design, this is a prototype. I will work with it. As you can see, there is quite a lot of space around the components. Yeah, for instance here, yeah. So this will be a board for the following work. I will change the component values. I will even, there is a lot of, as you can see, for instance, here, a lot of zero ohm resistors. So yeah, I noticed that this resistor should be unpopulated. Yes, even this one. So yes, a lot of components that are to be placed or not. I will play with it. The purpose of the board is a small current comparator. There are two LEDs, the red LED and the green LED. When there is a current higher than 10 milliamps, no, when there is a current higher than 1 milliamp, 1 milliamp, the red LED should be blinking. When there is current in between 0.1 and 0.5 milliamp, the red LED will be off and the green LED will be constantly on. And when the current is below 0.1, the red LED should be constantly on. Hope so. As I said, I did my best when capturing the schematic, but sometimes the reality when the PCB is assembled and tested is different. It's life. So let's continue. Thank you. Hello. Thank you, Amos, or Gideon. I'm not sure what's your first name. I hope I don't insult your feelings. Yes, the thing is that the StreamYard, this is the platform I'm using for streaming, has some lag in between you send the comment and I see it. So I'm happy that you agree with me, but right now I don't know what sentence or fact was agreed by you. Thank you, Prasad, as well. Yeah, as you can see, or maybe not familiar with KiCad, I am using KiCad. So KiCad is my #1 tool, not priority #1, but #1, only one. I use only KiCad. If you want, you can check my portfolio of all the content. Let me create a banner with the link. The link is not quite short, but I believe if you let Google up the 𝗏𝗏𝗀𝗏 guy, you will find something. If not, please check my LinkedIn profile and you will find more there. I will do the same with my profile. This is my LinkedIn profile, so LinkedIn and 𝗏𝗏𝗀𝗏HW is my profile. So let's get back to work. Thank you for the question, 𝗲𝗏𝗀𝗻𝗔. The board is a small current comparator. The power supply is the USB Type-C connector. When the current flowing from the V-bus line is higher than 1 milliamp, the red LED should be blinking. When the current is between 0.1 and 0.5 milliamp, the green LED should be constantly on and the red LED should be off. And when the current is below 0.1 milliamp, the red LED should be constantly on and the green LED green LED should be off. This is the projected behavior. I used 2 comparators, one window comparator, one simple comparator comparing the value like higher than 1 milliamp. Here is the current detector, current sensing device in a 214, some logic gates, and here is the blinking a stable multi-vibrator with the controlled input. Should be working, but as I said, it's prototype work and I have to verify the feature, the function. So hopefully it will work, but I will count, and I count with that there will be some issue with it. So instead of playing with breadboard is fine, but you have to have all the THD components, and when there is quite a lot of components on the piece on the board, like or in the schematic, I like to create a simple and low expensive PCB for it because it's much more reliable, easier to tune for me, and quicker. Yeah, all benefits. Breadboards are fine, but you have to have the components, a lot of wires, you have to be patient, you have to, when there is a lot of wires coming from the breadboard or across the breadboard, it's a mess, and I don't like it to play with a messy board. So yeah, prototype board.
Listening, head over to brain.fm or follow the link in the description below.
No problem. If you want to ask anything about the design process, KiCad related questions, design related questions, feel free to ask. You may ask why I don't connect directly below the package, the signals on port 6 and 9. The reason is, as I said, is the board will be prototyping, and I will probably change the schematic a little. And when there is a track below the package and I need to cut it out, it means that I have to unsolder the package, then cut the track and get the package back. This is not very convenient, so I don't. Here I used it because it's a comparator and I can configure the voltage levels with the dividers and with outer components. The comparator will stay the same. I will only change the levels. The comparator is ready to work as it should. What I have to do, what I might have to do is change the logical circuits, so the logic gates. So this is why I will keep the possibility to change the circuitry by cutting the small short tracks near the pads. So here I will use the via and connect it like this. It's not nice, but it's functional. The same here. Not very nice, not very, In a final design, I wouldn't do that, but on prototyping board, I preferably do this because it saves me a lot of time and troubles, because it's not so easy to cut out the track below the package. So let's get back to work. The same with the 555 stable multi-vibrator. It's a verified circuitry, and I can place the track below because I don't want, and I will not change the circuitry here. Just the values of the components. This is why the components are far from the package, to enable me to manipulate with soldering iron tip and like to give me some flexibility. The components are near the edge of the board, so the access to it will be comfortable, as well as these two output pads. I placed them close to the board edge because I use the hooks on the wire, on the cable. I don't know how to describe it. Let me find it. Yeah, something like this. Something like this. Or give me a second. Yeah, something like this. Similar cables. So these THT holes near the edge allows me to grab the hook to them, to the holes, and provide me with a comfortable connection without soldering. Those are test points for measuring. If I need to connect a wire, I can comfortably solder the wire on that place, because the test points are 2.0 millimeters in diameter, so quite big for comfortable soldering job. Let's get back to work.
listening. Head over to 𝗏𝗏𝗺.fm or follow the link in the description below.
Thank you for watching, and I'm done with this board. So see you next time.